Hello, Math 1050. This is Mrs. Bricky, and this video is for section 7.1. We'll be focusing on ellipse. An ellipse is, here's a diagram of an ellipse if it will load. An ellipse is the set of all points on a plane such that the sum of the distances from two fixed points is constant. So I have point A and point B, and point D is on the edge of this ellipse. It's like a kind of an elongated circle. That distance, if I measure the distance from point B to point D, it's 5.25. From point A, it's 2.05. Those add up to 7.3. You can see the sum right over here. And if I move to another point on the edge of the circle of the ellipse, you can see that that distance A plus B is always the same. So we're just finding every single point that has a sum of distances of 7.3, and that creates an ellipse. And if you move the foci so that they're maybe closer together, the shape of that ellipse changes a little. Right now, the sum of those distances is 6.47. So that creates this ellipse. The 2 points that when we deal with ellipse today, those 2 points will either be on a horizontal line or on a vertical line. So you can see now the distance is 6.47 still. But, in theory, they would not have to be on a vertical or a horizontal line. So we could have, this situation. Anyway, that's kind of the definition of an ellipse. So when we're going to graph an ellipse as our first topic here, we're going to graph the ellipse x plus 2 squared over 25 plus y plus 3 squared over 16 is equal to 1. Now, this graphing an ellipse is a lot like graphing a circle. So we start by finding the center. So this ellipse has a center at -2. So we're finding the 0 associated with this little x plus 2 squared, and then our y coordinate would be -3. Make sure you get those signs right. So here's our center. And now those denominators are telling you how far to count out in each direction. So in the x direction, we've got that 25, so we're going to count out 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that was in the x direction because the 25 is under the x. And then under the y plus 3 squared, we have a 16. So in the y direction, we're going to count out 4 because that is a 4 squared. So 1, 2, 3, 4, 1, 2, 3, 4. When we're graphing circles, we usually count out the same number in each direction because it is the same, radius in all directions. For an ellipse, those two distances might be different. So then you would just sketch the ellipse. On Alex, this is very easy. You'll just mark, the major axis and the minor axis, how far you want to go out in the direction of the major and minor axes, and it will sketch it for you. Here's one more. So the center of this ellipse is going to be at 2, -3. So +2, -3 is right here. And in the x direction, our denominator, we can't even see it there. That's the denominator of 1. So in the x direction, count out 1. So just a little skinny guy here. And then in the y direction, we're going to count out 4. One, 2, 3, 4. 1, 2, 3, 4. So whichever axis is longer is called the major axis, and whichever axis is shorter is called the minor axis. Okay, next topic. Our next topic is going to have us find some points on the ellipse, or some points, some of the characteristic points of the ellipse. It's going to have us find the center, which we have been doing and is very easy to find the center. It's also going to have you tell what the two vertices of the focus of the ellipse are and what the two focus points of the ellipse are. So the two focus points, remember for our definition, are the 2 points where you add up those distances, and it's a constant for the ellipse. So we're going to find those 4 points plus the center for a total of 5 points. Some of your ellipses are going to have a horizontal major axis, and then some of them are going to have that vertical major axis. So the 5 points, though, that you're going to find are always in a row like this. So either they'll be horizontal in a row or vertical in a row. You know how to find the center based on that we just graphed, and you know how to find the vertices because we were finding those when we were just graphing. What we need to talk about now is how do we find the location of the foci. For the foci, we are going to do a little calculation. C squared equals A squared minus B squared. On your Dixie State formula sheet, you do have this information. It uses absolute value bars on that formula sheet. That's just because it needs to be positive. Sometimes A is bigger than B, sometimes B is bigger than A. So you'll just have absolute value bar, just needs to be a positive number. And then to get C, you need to take the square root. And calculating C is helping you find this distance between the center and those foci. So let's try this one. So our circle is x minus 6 squared over 9 plus y plus 1 squared over 25 is equal to 1. I think that one of the best ways to do this and not make an error is to draw a really rough sketch. So it looks like our major axis is going to be a vertical one because we have a bigger number here. So our ellipse is going to be a tall one. The center of our ellipse, we can easily find. It is at 6, -1. Here and here are where we find those. So here's our center. So our major axis is here. So we can find those vertices. We've got a vertex on the top and we've got a vertex on the bottom. These are all on a vertical line, so they're all going to have the same x coordinate. So they'll both have that x coordinate of 6. Now remember from graphing, we need to count out in that y direction by 5. So if we add 5 to our center is at -1 and we want to add 5 to go up above it, then this one is going to have a y coordinate of 4. And to go down to this vertex down here, we would count out 1, 2, 3, 4, 5. So this is -1 minus 5, so that's -6. So we've got our upper and lower vertex. Okay, so now we need to find the foci. So we've got one foci here and one foci here. One focus, I guess. All right, so they have that same x coordinate of 6, and we need to calculate this distance. Well, if you compare to the formula sheet, this is our a squared and this is our b squared. Those are already squared numbers. We don't want to square the 9. This is a 3 squared. So a squared is 9, b squared is 25, and we're going to calculate c squared. So this is our a squared minus b squared. Well, 9 minus 25 is negative 16. So if we take the absolute value of that, c is equal to 16, which means that c is 4. So to find this upper focus, the coordinate is 6, and then negative 1 plus 4. So that puts it at 6, 3. And then our lower focus is negative 1 minus 4. It's 4 below the center. So this would be 6, negative 5. Okay, so that one's finished. I want to try a horizontal one just because sometimes people get confused. So this one, you can see this larger number is in the x direction. So we've got this sort of ellipse. Pardon my ugly drawing. Our major axis is in this direction. Our center right here is at negative 2, negative 4. To find the vertices, we need to think about counting out by this. 169 is 13 squared. So for our vertices, that y value is going to be the same. We need to figure out their x values. Well, we'll find those x values by adding or subtracting 13. So this one is 13 to the left, and this one is 13 to the right. But we're adding and subtracting from that x value, not the y value. The y value will stay the same. So this one will be negative 2 minus 13, which is negative 15. And this one will be negative 2 plus 13, which puts it at 11. And again, the y value is the same because they are on that horizontal major axis. Okay, so for the foci, which are here and here-ish, somewhere along there, maybe we don't know the exact distance yet, we need to do our quick calculation. C squared is a squared minus b squared absolute. So this one is 169 minus 25, which gives us 144. So C is 12. So we can find those foci by adding and subtracting 12 from the x-coordinate. So negative 2 minus 12 gives us negative 14, negative 4. And if we add that 12 to the x value, we will get negative 2 plus 12 is 10. So those are our 5 points. Okay, the last topic for Ellipse is word problem topic. So it gives you a nice diagram to look at. We've got a bridge that has an arched opening that's in the shape of an ellipse or a semi-ellipse because we don't have that lower side to it, of course. We have the arch in this case that is 164 meters wide or long, and the height at the center is 52. So we are trying to find the height right here that is 11 meters from the center. You might want to find that height out because you're wondering if a truck in this lane is going to fit or something. So I guess it would be like here. All right, so we are going to take these diagrams to be centered at the origin. So this is going to be the origin, and that allows us to put a 0 here and here, which simplifies the equation a little bit. So now it looks like x squared over a squared plus y squared over b squared equals 1. And it's good and convenient to do that because then, we're measuring these distances from 0. All right, so if we think about this ellipse in the x direction, that value a is just half of that 164. So our A value for this ellipse is 82. And our B value would be this measurement right here. So this gives me my two denominators. So our denominator A is 82, which is squared, and our B value is 52 squared, or B squared is. All right, so we're trying to find the height right here. Well, on this diagram, height is a Y value. And so if we think about this point right here, the coordinates of that point are, we moved over 11 and up. I'm going to call that Y because it's a Y value. So I don't want to use X because that might be confusing. So our X value is 11 for that point, and our Y value is what we're trying to calculate. So for X, I'm going to go ahead and fill in 11 with that power of 2. The Y squared is what we want to calculate, and that's equal to 1. All right, so if we think about getting that Y by itself, the first thing we might do is subtract this. So then our equation looks like Y squared over 52 squared equals 1 minus 11 squared over 82 squared. Our Y squared is divided by 52 squared, so we're going to times both sides by 52 squared. And so that gives us Y squared equals 52 squared times 1 minus 11 squared over 82 squared. And you could have typed things into your calculator somewhere along the way, but I feel like it's easier to just wait. So we know what Y squared is, so we can type this whole thing into our calculator just as is. And if we do that, we get, oh, I didn't write it down, some big number. And then to get Y, take the square root of that. And so if you do that, you should get Y is equal to 51.53. This does ask us to round to the nearest hundredth, so make sure you notice those rounding statements. And let's try one more of those with just a slight variation. So if we look at our diagram, we can get our A value here. 168 divided by 2 is 81. And our B value is shown to us on our diagram right here. So this time we're trying to figure out how far over, so that's an X value, does the bridges or tunnels height have a height of 19. So we don't know what the X is, and we know the Y is 19. So if we use that same idea to set up our equation, that will be X squared over 81 squared plus our Y value is 19 squared over 62 squared, and that's equal to 1. So using the same ideas as last time, X squared over 81 squared equals 1 minus 19 squared over 62 squared. Now we're going to multiply by 81 squared. It's like the world's biggest one. We'll type that into our calculator. And when you calculate that, you get 5,944.8394, blah, blah, blah. And then you're going to take the square root. Hopefully you would notice that that can't be the height. It's way too, or it can't be the distance. It's only 81 meters wide right there. So obviously the 5,000 can't be your answer. So if you take the square root, you get 77.10 meters. And again, we're rounding to the nearest hundredth. All right, that's it. Thank you.